the first one start off with just like we did with solving equations. Well, these are equations, but it's the same thing as inequalities. You want to just do the first step, find the like terms, combine those together, and then keep everything else the same. So that you have only maximum one variable, one number on both sides. And then just stop there, just like the same. Same thing on number 2, number 5, second part, do the distributing and the combined like terms. Just double check your multiplication, make sure everything's done properly, and then combine the like terms. And minus 35 in. And also watch out for when you have to distribute a negative, that those two negatives make a positive. On this one, but the left-hand side just stays the same. Go ahead and find what goes together. If you need to, you can underline it. It's easier. You can see it's going to be these variables. Like negative 35 plus 6 would be negative 29. And then we have negative 10 minus 24, negative 34. And then just stop there. Just practice doing the first part. Now, statistically, if you're going to miss a problem, it's usually going to be in these first two steps. That's why we're focusing just on these. If we make it to this part okay, chances are you're going to get it right. We really want to look at the first part. Yeah. Number 2, what can we combine? Can we combine 2 plus 4? No. 5r plus 10? No. That's already done. Yeah. So part of what we're doing is knowing, well, what if it's already that way? It's not like that we need to do this every single problem. So sometimes we have extra variables and extra numbers. Other times, like number 2, you don't. Well, you still have to know that that's already finished. You don't need to do anything. As opposed to always forcing and making something happen always. Yep, you can rewrite it. All right, going down to here, it's kind of assumed that when you're writing inequalities, you're going to write it with a variable on the left. So for all these, write with the variable on the left, and then you can go through, find the correct symbol, and then put the number. Because there's 2 correct ways of writing it, as you remember from the first assignment. This is also correct. It's just not the standard that we use to write inequalities of graphs. So you want to go with this first method, even though both of them are correct. It's kind of like if you write 5 times x, this means 5 times x. But so does this. X times 5, but we never write x5, we always write 5x. So in a similar way, both correct, but we tend to use one with the variable first. Okay? Lastly, no solution and all reals. I just want to go into a little bit information about no solutions and all real numbers so you know the difference very clearly. What you want to do is focus in on whether what you're left with is false or true. A false statement will lead to an answer of no solution always. There's equations or inequalities. Something false will lead to a no solution. Now this has no graph. So a graph, it says to solve and graph your answer. But if you get a no solution, don't worry about it. You can't graph it. The graph is here's where your answers are. So without an answer, you can't graph. Here's some things that are false mathematically. Anything's false mathematically. 1 equals 2. So if you got an end of an equation and said 1 equals 2, that would be a no solution. Negative 3 equals 3. Because they're the same number, they're different signs, that's still a no solution. They're both false. 0 is less than negative 1. Because 0 is not less than negative 1, right? This is not a true statement. So if we came to an end of an inequality, that would be false. Now here's something that's a little different, but also false. 0 less than 0. Yeah, that's not true. 0 is not less than 0. Now this is a little different because up to this point you might have looked at both of these or all three of these and said, well, okay, if the numbers are different, it's going to be false. But here the two numbers are the same, it's still false. 0 is not less than 0. So you can't rely on just, are the numbers the same on both sides or are they different on both sides? That would get you in trouble in just a few cases like this one. Okay. Another example, let's see here. Infinite or true would be the infinite or all real solutions. So we have all real solutions. All right. Or infinite. There we go. So some things that are true. At the end of an equation, if you got 1 equals 1, well, sure, that's true. If 0 equals 0, that's true. Right? If 0 is greater than negative 1, that is true. Right? 0 is bigger than a negative number, always. And also we have something like this. If 0 is less than or equal to 0, that is true because of the equal to part. Right? Because of this, it's not going to be the no solution that we got here. It's going to be true. So small but important details. Again, these are both the same number right here, and so are here, same number. But they are not the same answer. One has a no solution, one has an all real. Okay. Now let's not confuse that with an answer of 0. So we saw on the test, like two people had this, and they said, well, there's no solution. Well, there absolutely is. 1/2 times what equals 0? 0. Right? Answer is 0. So if you have a variable left over on one side, there's definitely an answer. It might be a fraction, it might be a decimal, but there's for sure an answer. The only way you get these no solutions and all reals is if there are no variables. You can see on all these, what they have in common is they don't have a variable. So this only happens when you have like the same thing on both sides, like this. And then when you subtract, it cancels both variables out on both sides. That's the only way to get one of these special cases. But otherwise, even if you have something really weird, like, I don't know, 3 over 17x plus 15 over 147 equals 1 over 148x, plus, I don't know, 3.5. 4. So the idea that if I go and start solving this and subtract on both sides, I know this will not equal 0. The only way for this to be 0 is going to be if this was minus 3 over 17x. So for sure, there's an answer. It might be some complicated, ugly fraction, but we're not going to say all of a sudden, oh, no solution. It's getting kind of hard. It's for sure there's an answer. We don't know what it is. But if this turned out to be, 3 over 17, and I subtracted 3 over 17x on both sides, and both variables canceled out, then for sure it's going to be one of these special cases, depending on what's left over, if the same number is true or false. Okay. So do not jump into, well, I'm not sure what the answer is, therefore it's no solution. Or there's fractions involved, and therefore it must be a no solution or all reals. Now, if you have a variable, you definitely have an answer. So see that, well, it's on the board already, so you can see that. And also don't forget, you can't have answers that are fractions. Do not, if you get like 12x equals 7, don't say, well, oh, you can't do it. Like, absolutely you can. You just divide both sides by 12. Reduce if you can, right? If not, that's your answer, 7 over 12. Just like we put in Khan Academy, just like we did on everything else. Answers can be fractions. It's perfectly fine. All right, so I'll leave you for the rest of the period to work. I'll be monitoring